Hi guys, so today's lesson is going to be on scatter diagrams. Now you need to be able to draw and describe a scatter diagram. And also you need to know about the different types of correlations. So let's get started, guys. Now first I want to show you the different types of correlation. So there's positive correlation, negative correlation, and there's also no correlation. So why do we use a scatter diagram? Now, we use this to compare two variables. So, for example, the temperature and the sales of ice cream. Okay, so when you're comparing two variables, you draw a scatter diagram to see if there's a relationship between them. So, does one of them affect the other? So, for example, here are some examples of negative correlation. So, negative correlation on the scatter diagram, you'll see the points going in this direction. Okay, so for example, that could be a student who has many absences has a decrease in grades. So let's say this is it, this x-axis is the number of absences and the y-axis is the grade. So as you can see, the lower the number of absences, the higher the grade is. As the number of absences increase, you can see the grade gets lower. Okay, some other examples of negative correlation are as weather gets colder, air conditioning costs decrease. So, also, if a train increases its speed, the length of time to get to the final point decreases. So, here the speed is increasing, but the time is decreasing. So, the faster the train goes, the length of time will decrease at the same rate. So, the last one, if a chicken increases in age, the amount of eggs it produces decreases. Yeah. So, as the chicken gets older, it will produce less and less eggs. So these two things, these two variables have a negative correlation. Okay. So positive correlation, guys, is when the two variables increase. So they have an increasing effect on each other. So, for example, the more time you spend running on a treadmill, the more calories you would burn. So, let's say the x-axis is time on treadmill, and the y-axis is calories burnt, number of calories burnt. So, as you can see, the longer you spend on the treadmill, the more calories you will burn. Okay. Now, the last type of correlation is no correlation. So this is when the two variables you're measuring, they don't have no relationship with each other. So for example, the color of the amount of times you do jumping jacks and the sale of bread. Okay. Okay, moving on now, guys. So here we have an example of how to plot a scatter diagram. So as you can see at the top, we have the length of a leaf and we have the width of a leaf. Okay, so we want to see if the length of a leaf is related to the width of a leaf. So for example, does the length of it affect the width of it? So for example, here we have loads of measurements of the length of leaves, so 6, 20, 10. Then we have some measurements of the widths. Okay, so what we have to do is just plot these points. So you can think of the L as your x-axis, the length as your x-axis, and the width as your y-axis. Okay, so plot your points on the scatter diagram. So remember to go along the x-axis first, and then the y-axis, so 6, 5. then 2015, 10.9. Yeah, so keep going, guys. Okay, now after I've plotted all the points, guys, I can now draw a line of best fit. Now the line of best fit goes through most of the points, and you're trying to get it so that there's the same number of points above it and the same number of points below it. So I'll show you what I mean, guys. So as you can see, this line, I've tried to get it so that 1, 2, 3, 4, 5 points are above it. 2, 3, 4, 5, and then around 5 are below it. 1, 2, 3, 4, 5, 6. But it's never going to be perfect, guys. That's why we call it a line of best fit. Okay, and it doesn't have to start from 0. Okay, it doesn't have to start from 0. It can start in the middle of your graph. Okay, now using the line of best fit, guys, I can estimate stuff. So let's say I have a leaf length that is 19. So sorry, the width of the leaf is 19. So I look on the width, which is the y-axis, and I find 19. So guys, 19 would be about there. Okay, sorry guys, not the width. I look on the length, so I find 19. Okay, then I draw a line and I stop at the line of best fit. Then I start going across. Okay, and as you can see, I read off whatever that value is, and it's 15. Okay, so how long would you expect a 10 centimeter wide leaf to be? So a 10 centimeter wide leaf, so it's 10 centimeters wide. So I'll look on the width, find 10, draw a line to my best fit, stop at the best fit, then go down and read off whatever that value is. So that value is 12.8, okay, or 13. Okay guys, so as you can see, this scatter diagram has a positive correlation. As one quantity increases, so does the other. The line slopes from the bottom left to the top right. Okay, so in real life terms, guys, as the leaves get longer, they also get wider. So if you get a question saying, describe the relationship between the width of the leaf and the length of the leaf, this is what you would write. Okay, so we can also use, so as I told you before, guys, scatter diagrams are used to compare the relationship, see if there's a relationship between two things. Okay, so is there a connection between the age of a car and its value? So let's have a look, guys. So along the x-axis, guys, you can see I have the age of the cars, and along the y-axis, I have the value in thousands. So 1,000, 2,000, 3,000, and so on. Okay, so here's my data, guys. Here are some ages of cars. So a 1-year-old car has a value of 9,000. A 10-year-old car has a value of 4,000. Okay, so first thing I do, plot all the points. I know you know how to plot all the points, guys. Now I draw my line of best fit. Remember I told you it doesn't have to start from 0. It has to go through most of the points. So here you go. Here's mine. Now using that, I can estimate. So how much should an 8-year-old car be worth? So 8-year-old car, I find an 8-year-old car which is there. Okay, then I draw a line, a straight line with your ruler going up to the line of best fit. Then I go across and I read off that value there. So that value would be 5. If it's going up, if there's 5 squares there, that means it's going up in 2. So that would be 5,200 pound. Okay, let's say, okay, so as you can see there, guys, they've got an answer of 5,100. In the mark scheme, guys, they do give you 1 or 2 squares Uh, so you can get an answer of 5,000, 5,100, or 5,200. Okay, so next one, how old should a car be when it's worth £7,000? So let's have a go at this one. So find £7,000 is there. I'll go across until I hit the line of best fit. Then I'll go down. So my value, so the age of the car would be 5.2 years. Okay, or 5 years. Okay, so guys, there are many examples you can go through. I hope you enjoyed the video today. Make sure you look out for the next video. Okay.